Good day everyone. I welcome you back to my channel. Today we are looking at triangles and we'll be specifically calculating the unknown values in each of the following triangles. And all lengths are in centimeters form. Now suppose you are given a triangle I'll call this example A. So we have our triangle. So we have sides here and we have 46 degrees and we have angle X and angle Y. N, we have angle N, O, P. Now, in order for us to start with this or finding these unknown values, which is X and Y, we need to identify a couple of things. We know that side N, O is the same as side PO. And what does this mean? It means that that is an isosceles triangle. Only because this side and this side are equal. Now, technically what this means, it means that X, or rather angle X, is the same as angle Y. Okay. Now, to move forward, we can actually start, that's now our inference here. Now, to move forward, we can actually start applying our conception or algebraic conception here. So we can actually start by saying angle N plus angle P plus angle O is equals to 180 degrees. Now, we can actually substitute these angles by means of our variables in this case. N in this case is X plus P in this case is Y plus O in this case is 46 degrees is equals to 180 degrees. So now what we need to do now, we need to make X and Y our subject of the formula. So we already have 180 degrees this side minus 46 degrees. So essentially what this means, it means that X plus Y is equals to 134, since we are substituting and subtracting 46 from 180. Now, these two angles, since they are equal, we saw that from here, and our second inference there, so we need to split them in two. So in other words, 134 divided by 2, X is equals to, so 134 divided by 2, X in this case is 64, and Y is also 67 degrees. So Y is also 67 degrees. Now, essentially what this means, it means that X is equals to 67 and Y is equals to 67, since I've split them in half. So now moving forward, or rather to confirm this application further, say X plus Y plus angle O is equals to 180 degrees. Now what this means, it means that, so now we just simply substitute this into our equation in this case. So we're going to say 67 degrees plus 67 degrees plus 46 degrees is equals to 180 degrees. So that confirms our application for this first example. Let's look at the next example. Our next example, we're going to look at example B. So now example B goes like this. So here's example B. So now B goes like this. So in this case, we are given another triangle. So a triangle. Okay, now, okay, in fact, we are given an exterior angle as well. So essentially, what we have here, we have x. Okay, this is our x. We're given a value here of 72 degrees. This is the angle there. And we're given this angle to be 34 degrees. So essentially, we have this angle R, S, T. Okay, so now we can start identifying this by saying, okay, we can have now, let's just make it easier for us. We have T1 and T2. Now we need to start calculating the unknown. To be able to start calculating the unknown first, by impression, we can see that obviously we have an angle of 34 degrees and 72 degrees. Now in this case, we know that the exterior angle, in other words, x is equals to the sum of the opposite interior angles. So now in this case, x is equals to angle R plus angle S. So now x is equals to, so now let's go ahead and sum up these two angles. So you have 72 degrees plus 34 degrees, we get 106 degrees. So essentially what this means, it means that this angle here is 106 degrees. Okay, now moving forward, we need to now find our angle, this angle T2. Okay, to be able to find T2, just to confirm this and then to convince ourselves in this instance, is to say now, since this is a straight angle, it's a straight angle, so we can just simply say angle T1 plus angle T2 is equals to 180 degrees, since they are supplementary. So T1 in this case is x, we found that to be 106 degrees plus T2, we don't know what it is, and then we just simply equate that to 108 degrees. So T2, or rather angle T2, is our substitute of the formula of which we need to find. So we substitute this, and then we bring this 106 over to become negative 106 degrees. So angle T2 is equals to, so now let's go ahead and see how much we get if we subtract 106 from 180. So we get 74 degrees. So which means
it's 21
this
hours.
angle here is a 74 degree angle. So now to verify this, you can just simply calculate it by saying angle R plus angle S plus angle T is equals to 180 degrees. Let's go ahead and substitute. Angle R is equals to 34 degrees plus angle S is 72 degrees plus angle T, in this case is angle T2 rather. Angle T2 is, we found it to be this angle here, which is 74 degrees. Let's see if it gives us 100, or rather indeed gives us 180 degrees. So 34 degrees plus 72 degrees plus 74 degrees, it indeed gives us 180 degrees. So which means our answer is correct. Let's look at other examples. Let's look at other examples. So we're going to look at example C. Example C. Okay, now let's look at example C. Now, example C, we are given another triangle. So this triangle looks like this. Okay, so a triangle. So we have angle T, U, W, and Y. So we have angles 59 degrees, X. Okay. So now we need to find the unknown angles, which is in this case they are angle X and Y. Okay, and then also given a value here which is 67 degrees. Now, to find the unknown values, I suppose we start with Y first, because since we have a straight angle, so we have Y plus 67 degrees is equals to 180 degrees. Now, to calculate this, we use our algebra. So we have 180. This 67 is positive on the side. If it moves over, it becomes negative 67. So we still have y as the subject of the formula. So let's go ahead and calculate 180 subtract 67. We have 113 degrees. So which means this angle here is 113, rather 113 degree angle. Okay, now let's find, we found x in this case, y in this case, so we need to find x. So I'm just gonna use a different color. So in this case, to find x, so we can just simply say, okay, now since y is equals to 113, so what we essentially can do is to actually find this angle to be able to find the missing angle. Or what we can do in this case, we can use our rule of triangles, rather the angle, this exterior angle, this angle is equals to the sum of the opposite interior angle. Since we have already found y in this case, so we can just simply say y is equals to, since now is the sum, we're going to say it's equals to angle u plus angle t. Okay, or rather we can substitute this by saying y is equals to, yes, we can still keep it as angle u plus x. So x is our unknown value, that's what we need to find. We know that y in this case, we want to find x, remember? So y in this case, we found it to be 113 degrees is equals to, u in this case is 59 degrees plus x. So now by substitution, we have 113 degrees already this side. So subtract 59 degrees is equals to x. So now we have 113 subtract 59. That gives us 54 54 degrees. It gives us 54 degrees. It's equals to x. So x is equals to 54 degrees. So this means this angle here is 54 degrees. Okay. Now, if it's 54, then we can just simply find this unknown value. I'll call this theta. It's our unknown value. So theta plus y, or u rather, plus x is equals to 180 degrees. Let's go ahead and substitute. Theta is equal plus u is 59 degrees plus x is 54 degrees is equals to 180 degrees. Now moving forward, so we know that if we add 59 onto 54, we get 113 degrees plus this theta here is unknown, is equals to 180. So theta is equals to 180 degrees minus 113 degrees. So theta is equals to, angle theta now is equals to 180 minus 113. So angle theta gives us 67 degrees. So which means this angle here is 67 degrees. So we found if you sum angle theta plus angle u plus angle x, we'll get 180 degrees, meaning that 67 plus 59 plus 54 gives us 180 degrees. That's for our third example, which is example C. Now let's move on and look at other examples. Let's look at D. Let's look at D. Now D, in this case, we're given this triangle. In fact, we're given, looks like similar triangles. So these are triangles. These are essentially just similar triangles. Okay, and you're given this angle here. It's different from that angle. Okay, essentially we have angle H, L, N, and then we're given another triangle. Oh, is this line not straight? Okay, should be straight now. Okay, so now we have this triangle here. So we have this angle here, and then we have this angle. Now angle R S T. Now we just need to look at the magnitude of these sides here. So we have 24 centimeters in this case. We have x, we don't know what x is, and then we have 15 centimeters. We have 15 centimeters, and then we have 18 centimeters. Now what we need to do is just basically looking at proportionality. That's what it essentially means here. So to move forward, we can just simply say, okay, now since we have 18. Okay, we can just simply write 18 over 15. Okay, we now just need to multiply this. Okay, we now have our 24, and rather 24, yeah, over x. Okay, let's go ahead and multiply 24. In fact, let's actually inverse, or rather invert this. We need to use the ratio. It's better to use the ratio. So in this case, what we need to do now is to look at this proportionality by saying x. So we know that for triangle HLN, in this case, we have 15 by 18. Okay, and then for the other triangle, we have which is a triangle RST. In this case, we have 24 by x. We don't know what x is, this angle here. So by proportionality, what you need to do, we just simply need to multiply these values. So we know that 15 multiplied by 24 gives us, okay, let's just simply multiply. So 15 multiplied by 24 in this case gives us 360. In this case, it's our side, and then 18 times x gives us 18x. Okay, so essentially what this means, we can now just simply divide by 18 on both sides. So notice our 18 falls off, so it cancels out. So 18 into 360 enters 20 times. So which means this x here is equals to 20. X is equals to 20 centimeters. Okay, so that's what it means. So we found our x. Okay, basically here what happens is just to use proportionality or ratios. So 15, this angle, this side here rather, and then our other side, which is that side of 18, which is our corresponding side, and then we have 24 this side there, and then x, the unknown there. So what happens is you multiply 15 by 24, you get 360, and then you multiply 18 multiplied by x gives us 18x. So if you cancel out, x will remain, and then 18 into 20, 18 into 100, 360 enters 20 times. Hence, we found 20 to be the answer. Now, let's look at another example. Very interesting one here. Let's look at this example. Very interesting problem indeed. Let's look at this. Okay, now here what we have, we call this example, or fifth example, which is E. So what we have here, we need to identify that we have another triangle first of all. So let me start by having, we'll just space it up here. So we have that, and then we have line running through like that. It's a horizontal line. We have a diagonal going that way. Okay. We have a right angle here. So essentially we have a right angle here. It's a right angle. So it's a 90 degree. So this is angle N, angle P, and then we have side X. In fact, let me use different color to indicate our angle X. Okay, and then we have our angles here. We have angle O, we have angle Y, and we have angle Z. So this side, angle YZ, or other side YZ, is a 92 centimeters side, the length, and then side OY we have 124 centimeters. Now I must emphasize that, or indicate that we have a right angle there. Now by inspection, can you see that we have two angles here, right angles? So let me just re-highlight these angles. So at angle Y, this we have a 90-degree angle, and at angle N we have another 90-degree angle here. That's what we need to remember. Oh, we also have another side here of 23 centimeters. So we have 23 centimeters. Side NP is 23 centimeters. Now, by inspection, it's very important that we look at this example or this problem and be able to identify some key issues with regards to this triangle or these two triangles. First of all, we can clearly see that we have a right angle, which already tells a right angle triangle, which already tells us we're going to have to use our Pythagoras theorem. Okay. Now, in this case, to use our Pythagoras theorem, because this side is opposite angle Y, so I can just simply call it side Y. So I'm going to use my Pythagoras theorem by denoting this using Y as a subject of the formula. So our Pythagoras theorem goes like this: the hypotenuse, which is Y squared, is equals to, so in this case I know that the sum of the sides of the vertical side and the horizontal side of this triangle are equals to the hypotenuse, or rather the square root of the hypotenuse. So in this case, how does it go? We're simply going to say now Y squared is equals to Y Z squared plus side OY squared by substitution. Y squared is equals to YZ. YZ in this case we have 92 centimeters plus OY we have 124 centimeters. Okay, angle Y squared still is the substitute of the formula in this case. So 92 raised to the second power, if you raise 92 to the second power, we get 8,464 plus, if you raise 124 to the second power, we get 15,376 y squared is equals to. So now if you add 15,376 onto 8,464, we get 23,840 centimeters. Now we need to square on both sides. If you square on both sides, the square will fall off, so we remain. So if you square that, 23,840, the square root of 23,840 gives us 154,40, round off to two decimal places. So what does it mean? It means that this side y is equals to 154,40. But that is not what we are asked to find. We need to find x. This is just for finding purposes, for interest, if one is keen to know what that side is. So in essence, we actually we've just used the Pythagoras theorem. Now, to find our x in this case, we need to start looking at certain proportions. So essentially what this means, it is the same proportionality that we actually had earlier on. So essentially what this means, let me actually highlight this. What this means, we have the base, the horizontal axis, rather, the side here, what we have, side YZ. In other words, YZ is 92. Okay, so by proportion, we have 124 centimeters on the side, which is this side versus that. So by proportion, we have to start with the horizontal side of NP. So in this case, we have 23. Looks like 23. So we have 23. There it is. This side there. So and then we know that x is what we need to find. So by essence, we need to multiply this together. So we need to say that 92 multiplied by 23 gives us 2,116. Okay, and then 124 multiplied by x gives us 124x. So when you divide this, you're going to say, okay, 124x divided by 124, and then 2,116 divided by 124. So when you cancel this out, x will remain with x. So 2,116 divided by 124, we get 17,06. Okay, let me just double check one thing. Just one thing that I need to verify with regards to this triangle. 1 second. This is example 3.4. So we're dealing with E. 3.4. 51. Let's just see. 51. So we have 92 multiplied by x. 92 multiplied by x. Let's see, 2 multiplied by x. Okay, so 124 divided by 3. 124 multiplied by 23 divided by 92. Okay. Oh. Okay. So 92. Okay. Right. Now our analogy was slightly off. Okay, now let's actually relook and revisit this problem. Just stop right there. Now, and initially, this problem, we said that we need to have. Okay, now let's look at the adjacent side. First of all, let's look at the adjacent side of this triangle. Especially triangle YOZ. So our adjacent side in this case is 124. So, and our opposite side is 92. So technically we can actually start by saying 92, okay, and we're still gonna have our 194. Now similarly with this triangle, so remember we are looking at similar triangles, not necessarily congruent triangle. Hence now we need to be able to identify that, which is critical in this in solving this problem. So in this case we actually gonna have 92, so we have x instead of actually having 23 in this case, so we have now 23 on the side. Yeah, that looks more like it now. So when you multiply this 92 times x, we have 92x, and then 124 multiplied by 23 gives us 2,852. And if you divide this by 92 on both sides, it looks more like it now. If you divide this on both sides, x, we remember the x, so 2,852 divided by 92. So divided by 92, we get 31. This looks more feasible now. So which means x in this case is equals to 31 centimeters. Okay, that looks more practical. Now let's look at F. So it's good that one practices all these problems so that you become accustomed to solving such problems. That's because these are parts of pre-calculus activities. So it's very important that you practice these. Solve these problems using feasible, annotations, and be able to do observant, applications, or rather looking at realistic mathematization. So let's look at another triangle. So in this case, I have this triangle, it's a right angle triangle. So our right angle triangle. So essentially we have angle Y, angle Z, angle W, and we have 12, we have X this side. So as all, and then 16 centimeters side YZ. So now to find X, this is classically our example of what's this? The Pythagoras theorem. So how it goes, I'm gonna actually have to denote two applications with regards to this. So we're gonna say we have side WZ squared is equals to, since this is the hypotenuse, the side here is equals to side WY squared plus side YZ squared. Okay, so we don't know what this side is, so we're gonna just have it as a subject of the formula. So WY, side WY, by substitution we have 12 squared plus side YZ, in this case we have 16 squared. Okay, WZ squared is equals to 12 times 12 gives us 144. Let me just double check. Yes, 144. And then 16 times 16, or rather 16 raised to the second power, we get 256. Okay, So WZ is equal squared is equals to 144 plus 256 gives us 400. And then if you square this on both sides, we have WZ is equals to, so the square root of 400 is equals to 20. So that is 20 centimeters. So we have 20 centimeters here. Now we could have also used our Pythagoras theorem by having this side x as the subject of the formula, and we can just simply say, okay, now here this side we can simply have our y. Okay, since it's our y-axis, so already have x being replaced already. Our hypotenuse will be replaced by x in this case, so we can just simply have here, we can just call this maybe say side w, because it's opposite angle w. In this case, we could have just simply said x squared is equals to y squared plus w squared. Same thing. So by substitution, just simply say x squared is equals to y squared is 12 squared plus 16 squared. X squared is equals to 144 plus 256. X squared is equals to 400. The square on both sides, x is equals to 20. Hence this 20 now is this value here. Okay. Now let's look at one last example before we call it a day. So let's look at one last example. One last example. Oops, sorry. One last example. Okay, one last example, we have G. Now G is another complex triangle. In fact, there are two triangles in this case. We have a triangle, there. It's actually a right angle triangle. Looks like this. Okay, and we have another triangle. Going that way. Okay, we have a triangle. These are right angle triangles. So you can clearly see those. Okay, we have side angle L, we have angle T, we have angle N, we have angle R, we have side Y, side X, and then this side is 12 centimeters. Sorry, it's not actually 12. In fact, it's 15 centimeters. We have 9 centimeters this side. We have 5 centimeters here. Okay, now we need to find our sides X and Y. First, by inspection, we can clearly see that there are two right angle triangles which are placed on top of one another. Okay, so that's the first observation that we need to actually apply. So to find this X, or rather this missing value here, the unknown value, so we can just make X the subject of the formula by saying LT squared is equals to TN squared plus LN. Oh, sorry, I ran out of space. I have to move away from the. I think let me write it down here. Side LT squared is equals to side LN squared plus side NT squared. Okay, so now let's substitute. LT, side LT, we have 15 squared is equals to LN. We don't know what LN is, so we just simply keep it as X plus TN. We know that it is 9 squared. Okay, so to make this, or rather substitute by substitution, we know that 15 squared is already the side minus, so we have positive 9 squared, so we're going to have now negative 9 squared, since this 9 squared moves over the equal sign, changes the operation, and then we only remain with x on the side. So 15 times 15 gives us 225 minus 9 times 9 gives us 81 is equals to x. So 225 minus 81 gives us 144, which is x. Okay. But before we even say it's just simply x, remember it's actually an x squared, keep maintaining x squared. So to square this on both sides, x, the square will fall over rather. So the square root of 144 gives us 12. So what this means, it means that side x is equals to 12 centimeters. Now that we found x to be 12 centimeters, we can go ahead and actually use our Pythagoras once again. Now, this time we gonna just simply say side. Okay, remember, very important to actually indicate this before we even move forward. This is our hypotenuse. This is the longest side of our triangle. So in this case, that's why we had to subtract 9 from this 15. So it's very important to actually consider this, because this is our hypotenuse. So in this case, our hypotenuse is y in this case. Okay, so how this applies, we say now. Okay, since we can just start with the original version of our Pythagoras theorem, we can just simply say r squared is equals to x squared plus y squared. By substitution, r squared is hypotenuse, rather in this case it's our y squared. We call this our y, this y here. It's our hypotenuse. X squared, okay, this version of x squared in this case is our 5. This side here, it's a 5 squared, plus y squared in this case is this x, which we found here to be 12. So we substitute that to be 12 squared. Okay, so we want to find our hypotenuse. So we just simply say y squared is equals to 5 times 5 gives us 25, plus 12 times 12 gives us 144. So y squared, 25 plus 144 gives us 169. Looks like a perfect square. So if you square 169, it gives us y. Remember, if you square this on both sides, we get y to be 13. So we have 13 centimeters. Now that brings us to the end of our application. Thank you for watching. Until we